Hey everybody, welcome to this physics video about transformers. This is going to be a one-time only special edition physics video from a non-physics student trying to explain some basic physics concepts. When I first hear the word transformers, I think of this. Yep, those movies are sure awesome, and that's definitely what I think of when I think of Transformers. I think of the movie, but those aren't the Transformers we're talking about today. Today we're going to be talking about the basic Transformers you see on every street corner. You see these lying around, you see them hanging up there, and you've always wondered, what do those do? Obviously, they make the electricity work right and allow me to use all the appliances in my home, watch television, charge my electronic devices. But today we're going to talk about some of the basic principles behind transformers, how they work, and how they're essential to changing voltage into and allowing us to use magnetic fields and other physics principles to manipulate electricity to our convenience and allow us to be able to use electricity in a voltage level that works with all of our household items. Okay, so now we're going to talk about how transformers work. In front of you on the screen, you can see a pretty basic diagram of transformers. We can see that electricity comes in from the left in a primary circuit, a primary current, and this is an alternating current. Transformers need alternating current to work, and that comes around an electric coil, and because we have the alternating current, we're able to create a magnetic field. And with this changing magnetic field created by the alternating current, we are able to change the voltage from the left to the right side. And we're going to watch a little demonstration here to show how this alternating current creates that magnetic field. So if you watch this little animation here, we can see that with direct current, the magnetic field remains constant. As shown below, the magnetic field's constant, it's not changing. So that doesn't allow for a magnetic field to be created across the two coils, as it would be constant. But with alternating current, which is what we have in all of our transformers, we can see that magnetic field changes. And because that magnetic field changes, it allows us to create that magnetic field with the electricity, and that allows us to be able to manipulate the voltage and change the voltages we're going to show in this. We're going to go back to our first diagram and look that over here. So now that we know that this alternating current, which gives us the magnetic field and allows us to change the voltage, we're going to talk about how that works. So the basic equation to calculate this is pretty simple. We get the voltage of the secondary coil, which is that one, over the voltage of the primary coil, which is this one, is going to equal the number of turns in the coil on the secondary coil over the number of turns in the coil over the primary coil. And because of that, we're able to manipulate our voltage pretty much by changing the number of turns we see. So for example, on this side, we can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 turns. And on the left side, there's only 4. So 1, 2, 3, 4, 5, 6. Sorry, there's 6 on this side and 4 on this side. So because of that, let's just say, for example, on this our primary voltage is 100. So we can calculate our secondary voltage and change it because of the number of turns we have. So our number of turns on the secondary coil, right here as we can see, is going to be 4. The number of turns of the primary coil is going to be 6. So if we do some basic mathematics, we're going to get the voltage. The secondary coil is going to be equal to, it's going to be 400 over 6, which ends up, sorry about that, yeah. It took me a second to do the mental math, but it's going to be about 66 2/3. So you see we're able to step down our voltage from 100 down to 66 2/3. We drop the voltage over 30 volts. So Usually what will be done is voltage will be dropped down from much higher voltage down to about 120 volts. And that is usually the voltage that we have in our houses. Okay, there's just a couple of other things to note about how transformers work. We need to remember that with transformers, we have these coils, but perhaps you've had the question up to this point, like, what is this metal for here? And why is it there? And that's a pretty good question. So the reason why is that we have this magnetic field. We can imagine the magnetic field running in between these two coils and the transfer of energy there. But basically what we see is that this metal is going to be in every single transformer, and usually, from what I read online, it is going to be iron. Now, the reason we put iron in there is we need a ferromagnetic material in between those coils to reduce magnetic field loss. So basically it helps, as a ferromagnetic material, it helps conduct the magnetic field and allows the energy transfer to happen between the two coils. And because of this, we reduce a lot of the energy loss and make this a lot more efficient. As we all know, we like to keep the power bills as low as we can. A couple other things to note here is we can see, once again, this is a step down in voltage, just like we saw on the last slide, where there's more coils on the left. We're going to be stepping down the voltage. So this one is also going to be a step down in voltage. However, if there's more coils on the right, that would be a step up in voltage. Typically, the transformers used right before we get to where we'll actually use electricity, like our house, these are going to be step down transformers, because we're trying to get the voltage into a lower volt form that most of our regular household appliances work at. Okay, everybody, just one more thing to note. Energy still can be lost in transformers. They're not perfect systems. There's some swirling currents that happen here throughout the magnetic field. These are called eddy currents, and energy is lost from eddy currents as heat. So we do lose some energy from transformers to heat. Also, a good thing to note is that not every transformer works in a simple diagram like this. There's also much more complex transformers that have more than just two coils and change voltages, and obviously have a lot of different inputs. So it can be a lot more complicated than what discussed here, but the basic principles of the use of the magnetic field and isolating coils and changing the voltage between them is the same. And just to review what we've learned, transformers need alternating current to work to function properly and create that magnetic field. And they're used to step down voltage. They can be used to step up voltage, and they also change the current. And all transformers have a ferromagnetic core. That's important to note. And I think that's it, everybody. Thanks for watching.